Hey everybody, this is Larry. You're watching me solve this problem live during a contest. I'm going to start the explanation and then it's going to go into some code review sometimes and then just me working on the problem. Let me know what you think about this format. Hit the like button, hit the subscribe button, join me on the Discord link below, and I will start now. Okay, Q3. Avoid floods in the city. So this one was a hard problem. Let's saying that, and there might be other different ways to solve it. If you watch it to the end, I'm probably going to do code reviews so then of other people's solutions. So then we can maybe learn other techniques. But my technique here is that the thing to notice is, and I actually, when I was solving this live, as you may recall, I actually tried to do some stack stuff, and then I like greedy and stack, but the problem with greedy is that it's not always right. In this case, n is 10 to the 5th, so you definitely cannot do anything slower than n log n, so n squared is out of the question. So what I did was noticing that, so basically each step of the way we look at each number at a time. So let's say we put in 1. Okay, that's good. We know that we have to so given that 1, I'm trying to think about a way to explain it in a way that you can also learn from, but it's a little bit tricky because what I did, to be honest, and you could watch it, the live portion of this video, which is that I just tried a few things and then got a few things wrong, and then mentally tried this until it worked. It's not the ideal way to think about some problems sometimes, but sometimes you have to grind, and when you grind and you get it, it still feels good, even if you get a lot of wrong answers like I did, because I tried two different greedy algorithms and it was a little bit off. But the less greedy algorithm though, it's that so let's say you put in a 1, so now there are a couple of logical statements, right? If you put in a 1, you're like, okay, let's see if in the future we have another 1. If there is, then we have to remember to clear the 1 before the next one. Same thing for 2. So in English, I think that makes sense. And that's basically my greedy algorithm. And if you cannot do that, then you return, the empty array for not able to do that. So of course, in this case, the implementation is tricky, right? Because if you do it naively, then it's just going to be, okay, let's look at a 1 and then let's look at find the next one. And that's going to be all of n squared. As we said, that's too slow. So what I did was I actually implemented with a heap. First of all, it's kind of tricky, even though it's only 25 lines of code. So definitely take your time and stuff like that. But the idea is that for each, so first we do a pre-processing step, so that for each lookup, for each number, we just basically put it into that numbers with mapping a number to the index to an array. So now, for example, 1. So after one loop, for example, okay, let's just go to this case because that was the one I had trouble with anyway. So after one loop, actually we could visualize it by running it, right? So hope this helps. But basically, okay, well, it helped a little bit. But basically, 1 is in position 0 and 5. 0, okay, 0 is a little bit off because I forgot to take off 0. Okay, but 2, for example, is in position 2 and 6. 3 is in position 3, right? Okay, so that sets up the heap. And now we set up, and then now we go through again from left to right. So we go, okay, let's look at, now that we look at 1, we put it, if there's a 1 left in the rest of the array, that means we have to clear 1 in the future. We'll put it in. And what I did was I put everything in a priority heap, or priority queue, which is a heap. So for 1, I put in 1 with an index of 6. or I think it was 6, right? Or maybe 5. Yeah, sorry, index of 5, right? So now after one loop, the heap will contain, the index 5, and just tracking that as a 1. And then at 0, it just tries to remove anything that it needs to do, right? Because you know that you need to do. And then here, it just clears up to 1. And then 2, same thing. It goes to, I think, 6 now in 2. And then at 3, we don't put on the heap because we don't have to clear the 3. We don't see it later on. And so then like the 3, you could just pretty much ignore it. And then for 0, now you remove the heap again, and then that's good. And then now by the time we do 1, we know that it's clear, and we keep a set to make sure that that's the case by adding and removing as we go on. And same thing for 2. I think there was another case that illustrates the other case where, here, for example, I mean, there's some variation on this one, but basically the key note is that, given that 1 and 2, then we know that 0, 1, 2, 3, 4. So there's a 4, and then there's a 5, 1. And in this heap or priority queue, we put the 4 in front because that comes in earlier. So the idea is that we always take the item that is the earliest that we need, and then clear it on the next possible spot, which is next 0. So that's kind of the algorithm I have. What's the complexity? So the complexity is n log n. This is O of n because each item is going to be appended to the lookup at most once. This assumes that, of course, hash tables or dictionaries are all one lookup. You could do your own math otherwise. I know that, there's collusion and stuff like that, but let's just say it's all of 1, right? And then for addition, this does, because we use a deck, so we could remove from the beginning. So this is all of, well, each item can only be removed once, so this is in total O of n, where this is at most log n, given n of these, so this is O of n log n. In the else statement, we only pop each element once, so it's also O of n log n here, so O of n log n total. The space is going to be O of n for the heap and the dictionary. So O of n log n time, O of n space, and that's how I solved this problem. I did it a couple of times and it was hard, so don't feel so bad. But yeah, this is pretty hard for an interview and probably relatively hard for competitive programming, or at least in Leetcode competitive programming, to be honest, because I expect it to be easier, to be honest. But anyway, that's all I have. There's some beautiful ASCII art that we're going to skip. I think this uses the same technique that they did, but so if this is greater than 0, we have to set -1, and then we put stuff. What is OR? I see. So it's just looking backwards. That's an interesting way to do it. So the idea is that if you get a 0, so it's parsing it one by one, but if you get a 0, you put that index in there, and then otherwise you greedily. Okay, I see it. So basically what this problem is doing is that it's the other way, right? So you have a 1, you put everything that that is not clear into a set, or with the table, or with a set, and then you kind of keep track of the last 0 or the first zeros that you have available to you, and then when you see a number that you already seen before, you go back and you clear it for that number. Actually, that's pretty clever, and okay, that makes sense. So you use a yeah, okay. I mean that makes sense to me. Okay. I don't know if I could come up with it though, but I might have to think about it some more. But yeah, got it way faster than I did. Okay. Q3, avoid flood in the city. So this one I had trouble with as well. Basically, I thought that I could use some greedy algorithm, and there are a couple of times a couple of greedy strategies that I did on this one. Not neither, a lot of them didn't do that hot, um, but I thought that I could maybe use a stack to kind of figure out what to clear out by going backwards or something like that. But it didn't really order. Um, yeah. Didn't really work. I mean, here at this point, I was just proving to myself that that's what I need. I think I knew what I thought I knew what I wanted, but to be honest, I think I was a little bit off when I was in during this. Because at the time I thought that I could do greedy um, and then that'll be good. But I was wrong, as the test cases showed me, and I got three wrong answers, or two wrong answers on this one. But um, it's a very sloppy contest for me, kind of. And sometimes greedy algorithms are hard to prove. Um, I mean, they're not hard to prove, but they're hard because you have to prove them to a certain degree. And I wasn't able to do this on this one. So what I did was I looked at the examples and I was not convinced that I was wrong. So that was good enough for me to keep going. Some of that is a little bit on the meta. Q3 is not usually it's usually not hard enough that I needed to do anything tricky. So I just try to do it as the first thing that comes to my mind, which sometimes gets me into trouble, like in this case. But yeah, sometimes you have to trust yourself, and today trusting myself wasn't that great, though. But it works. I mean, it's okay. It's part of the learning experience. uh, some days you trusting yourself will really pay off, and other days, well, you just trust yourself to learn afterwards, I suppose. But yeah, so now I am trying to go backwards by, and then I thought that by going backwards uh we just fill out the colors as it goes, or sorry, like clear out the rain as we need it. But it was, well, technically it's okay. It was missing an invariant that I didn't really think about, which is that, or the condition that I didn't think about, which violated this invariant, which is that you don't need to clear out a lake unless you unless it gets rained on again. So if something happens only one time, you don't clear it, or you don't need to clear it anyway. You could clear it if you are bored. But yeah, but I had this really simple stack solution, which is wrong. But what I'm doing now is that basically and I don't know if I need to explain the wrong solution, because if it's wrong, but I thought that you could basically match 0 with the last number that we need to clear, and then kind of go that way, and that's what the stack would give us. But again, it is wrong because I missed that one scenario a very big scenario where the numbers don't, you don't have to clear numbers that don't exist. Yeah. I ran the test cases. It looks okay. Oh, okay. Maybe not the. Maybe not this one. Just forgot to initialize the array. And as soon as it looks okay, I was going to submit. Of course, at this point, I knew that I have to return an empty array, which I didn't do yet, but that's okay. It was just to kind of see where if my approach was okay. It's not, but it passed this example cases. That's why I was able to write the second half, which I reuse anyway. So it's not a loss. But of course, if it was not right at all, then I would not have approached it yet. Oh yeah, and I also just forgot the API a little bit for set for remove. I said it doesn't happen that often that I need to remove maybe. Basically, this is just a very naive algorithm. Basically, given an answer that I came up with, we just see if it's in the set. If it's not, then we add it. If it's already there, that means that it's not possible. Otherwise, we remove it when we need to remove it. And that's pretty much it. The answer, and it's right answer for the inputs, but it's wrong, as we'll find out. But I was ready to submit. And I got wrong answer. I was like, oh no. Why is this wrong? So this is wrong because the second two, we tried to print, we tried to clear the day for the second two, but we don't need to clear the day for the second two because, oh sorry, before the second two because, well, it's not set yet. So that's what I thought was my mistake. So I try to fix that, which is true because you cannot clear a lake before you fill it. I mean, you can, but it's right. So that's kind of the strategy here. Right now, I'm just thinking about how to go about implementing this. But yeah, I just go, okay, if the number is done, we don't have to push it. That's basically my attempt to solve this or fix the bug. Because I was like, okay, if you look at it in order, the first two, well, you don't clear it before you serve the first two because it's unnecessary. So that's basically what I'm thinking of here. Apparently I really took my time here, but oh well.
Okay.
But yeah, now what I was trying to do to kind of fix this by hacking is by looking at adjacent values. Oh, sorry, we keep track of the counts, and then if we get to 0, then we're good. I thought I had to start over, but then I was like, oh, maybe I can just hack what I already have, actually. Unless I misremembered.
This is roughly right. I just need to handle one case.
Yeah, I basically just go, okay, if the count is positive, or sorry, if there's 0 left in the count, then we just don't pop it, and we also keep track of the count as we pop stuff. Yeah, and the answer looks good. I was like, yeah, okay, let's submit this. I think I was a little bit YOLO on this one because, to be honest, even then I was not very confident. Oh, you have to move this back up, but I think some of it was that I expected Q3 to be slightly easier, so I was like getting a wrong answer. Oh no! Oh no, I was just running the code, not yet. But I do get a wrong answer, so spoiler alert. I was like, okay, that's a little sad. Use my debug print statement to kind of see. But yeah, the reason was basically I tried to clear 1 first.
To be a 2 first,
and so that was not good enough.
We
wanted to clear.
It has to.
We want to clear. Sorry, we cleared them in the wrong order between the 1 and the 2.
Oh.
So that's kind of why
a lot of people got this wrong. So
yeah, and I clicked the refresh button, and I was like, wow, a lot of people failed this, and only 35 people got it right so far. So I knew that I was not fast, but not like I was in good. Like I just to kind of get a gauge of the difficulty a little bit and try to think: is there a dumber way that I can think about this, or am I missing something obvious? At this point, I was just convinced that I'm being dumb, and that I needed to kind of start from scratch, if you will, because I basically reformulated or kind of go with the explanation or the really kind of ask myself what problem am I trying to solve with this problem. And it is that for each 0 we want to get the next index that's coming up that's clear. So what I end up doing was using a heap. And basically what I do now is for each lake that appears, I put it in a hash table of lists so that we could kind of keep track of all the indexes in which it happens. And now that we look at each key, I was trying to think about when to put items into the heap. That's basically what I'm doing at this moment. I was like, okay, you only want to put items in the heap if there's at least one entry, right? And I was like, is that really the way to add this? It's a min heap, okay. And also that it is a min heap in Python, which is not common. But yeah, and I was like, I don't need to relax it yet. So what I'm going to do now is, if it rained on a certain number or lake, well, if it's not cleared, then we return the empty because then we haven't cleared it. Otherwise, we put it into the set, we mark it as being rained on, and then we try to find the next time that index comes up. If that index doesn't come up, then we don't push it to the heap. But if it does come up, we take the next element that is bigger than this index and then put it in the heap. And the idea being that when we take things out of the heap, we always get, because we're sorting by the index, we always get the next element out of the heap. Or sorry, yeah, the next upcoming element, the one that comes up the soonest from the heap. And basically this is what I do. And going through the lookup array, I just go, okay, if the index is, that means we just remove stuff that we already like don't have to consider because it's in the past. And then we look at the first index after that and then put it inside the heap. And then now, when we need to take things out of the heap, meaning when we have a 0 and we try to figure out which one to clear, we just take the top because that is the item that is the closest to you. That's coming up the soonest. And that's what I do. And then later on, I just double check that. I just double check that we remove the right one. Or that it is possible to implement this solution. Yeah, and we only take the first element if the heap has at least one element. Otherwise, we just I put 1, but you could really put any number. It's just a placeholder because it doesn't matter what you have because it doesn't affect the output in either case. And to be honest, right now, I was a little bit doubtful that I was getting it right because when you already have 2 wrong answers, your third one, I was trying to be like, okay, let me think about it a little bit first. And then I submitted it. And I got accepted. Yay! I was very thankful and very happy that